Every autumn, the Tonglu mountain in Hubei province takes on a distinctive purplish hue as a small flower bursts into bloom. It's known as copperweed and only blooms in soils that are rich in copper. There's a theory that it was these very flowers that alerted the people of Bronze Age China to the presence of copper in the Tonglu mountain. Thanks to the groundbreaking archaeological excavation that began in 1973, we know for sure that Bronze Age people knew of the existence of copper in the Tonglu mountain and were mining it on an industrial scale. But there's more to mining than just digging stuff out of the ground. A range of technical issues need to be tackled, such as ensuring adequate ventilation. This must have been a problem in a mine as big as the one found on the Tonglu mountain. The deeper a mine is, the higher the temperature, leading to obstruction in airflow and insufficient oxygen. Even with today's technology, getting fresh air in and toxic and dangerous exhaust gases out of a mine is a challenge. How on earth did they cope back in the Bronze Age? Since the 20th century, the use of electricity has made underground ventilation and lighting less of a problem for mining and metallurgical workers. This is a 110 kilovolt substation built next to a modern copper mine. It's capable of meeting the mine's demand for power in its entirety. A reliable source of power is absolutely essential for a modern copper mine. In a modern copper mine, blowers circulate air, while ventilation doors help control airflow by isolating sections of the mine. But both these techniques depend on electricity. How did ancient miners keep air circulating 40 to 50 meters underground without a ready source of power? What's clear from the layout of the ancient mines in the Tonglu mountain is that the ancient miners were well aware of the importance of good ventilation. There's evidence to suggest that abandoned shafts connected to the surface served as ventilation shafts. But how did they get potentially dangerous exhaust gases out of the mine without electrical blowers? One possible answer to this problem could explain the dozens of burnt bamboo sticks uncovered by the archaeologists in the course of their excavation. What exactly were these bamboo sticks used for? Legend has it that during the Three Kingdoms period, Zhuge Liang, Prime Minister of the Shu Kingdom, used the principle that hot air rises to invent the sky lantern. But some speculate that the same principle had long been applied to copper mining. As early as 3,000 years ago, they argue, miners were lighting fires at the bottom of mines to heat the air at the bottom and make it rise. The currents generated in this way would help flush exhaust gases from the mine, meanwhile sucking fresh, cool air in through the ventilating shafts. But others disagree.
我们认为它是一种照明来用的这种走火线。为什么恰恰它为什么是遗留只有25到30公分的这个长度呢？我们认为它比较适宜人的手在拿到这个走火签的时候，燃烧的这个长度。
According to this view, the bamboo sticks were used for lighting and had nothing to do with ventilation.
也有学者认为，那个时候照明应该还是利用油脂之类的东西，因为油脂它可以控制它的火势。你要用来照明，必须要能够控制火势。如果不能控制火势的话，就像这个电一样，你如果控制不住它，就像闪电，你控制不住它，它就不能够用来照明。
Ultimately, we'll never know precisely how they mined copper in the Tonglu Mountain. After nearly 3,000 years, much of the evidence has been lost. All we can hope for is that further archaeological excavations will reveal overlooked details that will help us distinguish solid fact from speculation. Whether our ancestors used a combination of fire and ventilation shafts, one thing's for sure: copper can't be mined bare-handed. What tools did they use to hack the precious ore from the earth? Luckily, many of their implements came to light, providing us with a vivid picture of the day-to-day working lives of the miners. But other questions remain shrouded in mystery. What of the 13 bronze axe heads? Who on earth could wield a whopping 16-kilogram bronze axe? What role, if any, did they play in the mining process? Maybe a look at modern copper techniques can cast some light on these mysteries. In the 21st century, copper mining is a highly mechanized process that combines a variety of high-end technologies. When dealing with large underground rocks, the mining engineers need to determine where to drill, what sort of drill to use, and whether to use explosives. Based on their calculations, the most effective way of getting to the valuable ores can be adopted. The water used in the drilling process not only prevents the drill from overheating, but also keeps dust to a minimum. But the miners of ancient times had no explosives. How did they break huge rocks almost 100 meters beneath the ground? The 13 bronze axes may provide a clue. Unlike modern axes, these bronze axes are rectangular in shape. While the handles of the small axes slotted directly into the head, the larger ones were cast with holes left in them. The really huge bronze axes, meanwhile, possess 3 holes forming an isosceles triangle on one side, suggesting that the ancients were well aware of the stability afforded by triangular shapes. But though such axes would have been useless for cleaving and chopping, marks on the blades and sides of the giant axes indicate that they were used for hitting hard objects. So, if not for chopping, how exactly did the ancient miners use these heavy axes? Some speculate that the giant axes were created in order to make it easier to move large lumps of ores by using the principle of leverage. Another possible argument is that they were suspended and swung, transforming the huge axe heads into a powerful rock-chipping tool. But wait a minute, why would anyone discard such a valuable tool? Even if it had become obsolete, bronze was such a valuable commodity, used to make weapons, tools, as well as the great sacrificial vessels that represented the power of the state, that it seems inconceivable that these giant bronze axes would be simply tossed to one side and forgotten. Why were they left here?
他真是没办法，那是排水排不及了，已经是真没办法，非放弃不行了。
In some places, the ancient mine workings on the Tonglu Mountain reach below the water table. Flooding would have been a serious problem. Could it be that a sudden surge of water forced workers to flee, leaving their valuable tools behind in the rush to get to safety? This theory draws attention to another intriguing thing about the ancient mine. No human bones have been found in the mine.
但是我佩服，就是说，就这样的话，没有看到有淹死人在里边，也没有看到垮塌，这当年的这个支魂墓的结构确实是很先进的，应该说是。
Time flows relentlessly, ever onwards. From the Tonglu Mountain covered with copperweed, the mining and metallurgical technology and civilization developed here has been passed on and down the generations. From ancient times to the present, human wisdom continues to create new wonders. The discovery of the ancient copper mines in the Tonglu Mountain lifted the veil on a vanished civilization, once shrouded in mystery for thousands of years. As the excavation proceeded, some of the experts became intrigued by the rubble and gravel found in the weeds near the old mining tunnels. Composed of flat fragments, these stones were heavier than the usual type and showed signs of being worked. As more and more stones like these were found, the archaeologists became more and more puzzled. What were these things? When the composition of more than 100 pieces of gravel was tested, their average copper content was found to be no more than 0.7%, while their iron content exceeded 37%. In other words, the copper in the ore had already been fully extracted. This gravel could only be the slag, the refuse of copper smelting that took place here more than 2,000 years ago. A comprehensive survey shows that the slag is distributed over an area of 140,000 square meters, reaching a depth of over 3 meters. The combined weight of the slag is estimated to be no less than 400,000 tons. Few ancient slag heaps of this size have been discovered, its nearest rival being the 2,000-year-old slag heaps of Meroe in Sudan. Faced with the ancient crisscrossing mining tunnels and extensive iron slag heaps from more than 2,000 years ago, archaeologists began to wonder if these black stones were indeed slag. Then it followed that the copper mined on the Tonglu mountain was also smelted here in ancient times. In the summer of 1973, at the site of the ancient mines, archaeologists from all over China sifted through thousands of years of dust to trace the tracks of history buried for thousands of years. On a hillside, not far from the mining site, a mound made of stone and earth caught their attention. The mound looked like the fireplaces used in villagers' homes, but much larger. As the archaeologists carefully cleared the debris at the top of the mound, they felt they were one step closer to the ancient people who built the furnace and smelted copper. At the top of the pedestal they found holes, ones that had clearly been deliberately made. Over the next few years, several more pedestals of the same time came to light. If they were part of an ancient smelting furnace, how did the ancient people smelt copper from stones? In the 21st century, copper is widely used in electric appliances, light industry, machine manufacturing, construction, space industry and national defense. But how did this immensely important metal first come into people's lives? In nature, copper exists in two natural states. The first one is natural copper, present in such small quantities that today the only place you're likely to find it is in a museum. The other is copper-bearing ores, rocks such as malachite and chalcopyrite. The only way to liberate the pure, usable copper locked up in these rocks is by a process known as smelting. The useful properties of naturally occurring copper probably became known in the Stone Age. But there's a huge difference between being able to use small quantities of naturally occurring copper and being able to smelt it from rock. How did people learn how to do it?
在跟陶器的烧造过程中间，有的矿石可能就当时作为衬垫的东西啊，在高温底下融化了，于是就发现一个觉得这个是变成一种金属了，而且它越用的是，尽管那个时候铜的韧度还是比这个硬度比较软弱的，可他觉得还是很锋利的，所以就慢慢就琢磨了。
Perhaps it was a chance discovery during the pottery-making process that inspired our ancestors to get copper from ore. The key to the smelting technique is to make sure conditions in the furnace are calibrated correctly. Nowadays it's relatively easy to analyze the chemical composition of a sample of ore and to charge the furnace accordingly. But how did the ancient people manage to do it? Around the ancient smelting furnaces, mud ponds, screening yards, slag pits and crushing tables have been unearthed, pointing to the existence of an entire smelting infrastructure. This shows that the ancients already knew how to sort ores and process them for the furnace. In fact, these methods of selecting and crushing ores, although thousands of years old, are not vastly different from the ones used in modern copper smelting. Essentially, all that's changed today is speed and scale. Roaring mechanical crushers capable of processing hundreds of tons of ore per hour have replaced human labour power. Melting point tests of the ancient slag show that the furnace temperatures of the ancient smelting furnaces were capable of generating temperatures between 1100 and 1200 degrees Celsius. Two conditions are necessary to reach such high temperatures: a sufficient quantity of high-quality charcoal and an adequate supply of oxygen. How did the ancients solve these problems? Many have speculated that bellows were commonly employed in ancient smelting. Some even believe that the ancient Chinese had already mastered the technology of the bellows, and the only reason why no direct evidence of their existence has been discovered is that the animal skins from which they were made decayed long ago. The ancient book Mo-Zi, written more than 2,000 years ago, shows bellows made of cowhide. Holes in the furnaces have been identified as the inlets through which the fire was supplied with air, most likely by means of bellows. So it's not far-fetched to suggest that the ancient people were using primitive blast furnace technology on the Tonglu mountain. The same basic principle that drove the furnace for thousands of years is still powering the world's largest modern-day copper smelting furnaces. The only real difference is that the cowhide bellows of the past have given way to up-to-the-minute computer-controlled oxygen injection systems. We'll probably never completely understand the forces that drive human progress. But finding out how our ancestors solved their technological problems helps us look ahead into the future, as well as gaze back into the past.